we've already discussed the fact that log functions are inverses of exponential functions, so they undo whatever exponential functions do. So I've sort of suggested that one of the biggest uses that we're going to see of log functions is that they're going to now allow us to solve exponential equations, because they're going to give us a way of undoing that process of exponentiation. But logs are actually used in and of themselves, just in their own right, in several applications. Now, as with the exponential applications that we took a look at, I'm not expecting you to have most of these formulas memorized. In fact, with logs, you don't need to have any of these formulas memorized. With exponential functions, I do expect you to know the formulas for interest. Other formulas would be given to you on exams and quizzes. For log functions, any formulas involved for applications would be provided, and you're just being responsible for how to use them. But one of the interesting applications, particularly since we live in California, is the Richter scale for measuring earthquakes. So M is the magnitude of an earthquake, and that would be the measurement that we get on the Richter scale, okay? And it's defined as a log. It's the common log, because you'll notice I haven't written any base here, of this ratio, where I is the intensity of the earthquake, and that's basically measuring the amplitude of the shock waves that we have, okay, divided by I naught. That's the intensity of a zero-level earthquake. That's sort of our reference point, our point of comparison. That's basically the least intense earthquake that our technology can still actually detect, okay? So we're basically always looking at comparing the intensities by looking at this ratio. And it turns out that ratio is often quite a big number. And so by taking the log of that, that actually gives us smaller numbers. So on the Richter scale, we've talked about earthquakes that are maybe a 5-point-something or an 8-point-something, which is actually a huge earthquake. But we're not talking about huge numbers, even when we're describing very huge things. So that's one thing that logs can do. It can take a big number and just scale it down so that we're dealing with smaller numbers. Okay. So, for example, I want to find the magnitude of an earthquake whose intensity is 10 to the 5.1 times the intensity of a zero-level earthquake. Now, that's a fairly big number. That's bigger than 10 to the 5, and 10 to the 5 would be 1 followed by 5 zeros, so that would be 100,000. Okay, so this is 100,000 times more intense than a zero-level earthquake. If I wanted to find the magnitude, it's just going to be the log of 10 to the 5.1 times the intensity of a zero-level earthquake divided by the intensity of a zero-level earthquake. Oh, how nice. Those cancel, so we're just looking at the log of 10 to the 5.1. That's an exponential function with base 10. Being plugged into the log function with base 10, they undo each other. That's 5.1. So rather than saying, hey, this is 100,000 times more intense than a zero-level earthquake, we say its magnitude is 5.1. Notice that's a much smaller number than this is. So it really changes the scale of the numbers that we're working with. Okay. Now, that can mean that we don't have a super great intuitive sense of what these numbers mean. So let's say we said this earthquake had a magnitude of 5.1. What if I had a magnitude of 6.1? Those numbers don't seem super far apart, but if I wanted to compare the intensity of those, when you're comparing the intensity, you're just looking at this ratio. So I would say 6.1 would mean the intensity. If M is 6.1, that means the intensity is 10 to the 6.1 copies of a zero-level earthquake. And if the magnitude is 5.1, we just saw that means the intensity is 10 to the 5.1 times the intensity of a zero-level earthquake. So if I compare those by looking at that ratio, 10 to the 6.1 I naught over 10 to the 5.1 I naught, the I naughts cancel. Now, when I'm dividing exponential expressions like this, I can just subtract the exponents. So this would be 10 to the 6.1 minus 5.1. That's just 10 to the first, that's 10. So if the intensity is just one more, that's saying it's 10 times as intense. So going up 1 on the Richter scale is going to make your earthquake 10 times as intense as the other one. Let's suppose my magnitude was 7.1, 2 more on the Richter scale. That would mean the intensity was 10 to the 7.1 times I naught. Now if I compare that to my original earthquake, 10 to the 7.1 I naught over 10 to the 5.1 I naught, those cancel. I'm going to get 10 to the 7.1 minus 5.1 is 10 squared is 100. So something that's 2 points higher on the Richter scale is 100 times more intense. Basically, every time the magnitude goes up 1, the intensity gets multiplied by 10. So if it goes up 2, it's 100 times as intense as the original. If I had something of magnitude 8.1, that would be 1,000 times as intense as our 5.1 earthquake. So that just gives you a little bit of a sense of how that Richter scale works. There aren't a ton of problems about this in the homework, but there are a couple that do ask you, either given the intensity, to find the magnitude, and then ultimately generally to compare the intensities. And then you're looking at just this ratio of the intensities. Now, I've done examples that were very nice where we ended up getting integer powers of 10. If I had something like 10 to the 2.1, because I was looking at a 7.2 instead of a 7.1 earthquake, then I would just use a calculator. Okay, so feel free on problems where you're evaluating powers to non-integer exponents, feel free to pull out your calculator. Absolutely, that's expected. And then I would not expect you on a quiz without a calculator to be able to evaluate 10 to the 2.1, but I would expect you to be able to evaluate 10 squared. So I will rig the problems on exams and quizzes where you don't have a calculator so that they are doable without a calculator, but make sure that you're practicing the questions with a calculator, both because they give you a sense of how this stuff works, and because I might just tweak the question a little bit to make the numbers a little bit nicer so that you can practice that same skill, but without a calculator on an exam.